So let's take a look at the autocoder with Opus, but with auto debugging features. This one can run auto debug, run code, and actually get feedback automatically using your local system, or it can also do and run through Docker containers, and it actually manages the containers automatically. And the containers are set up based on auto requirements and a name which you give them. And so depending on the file that you're working with, you can modify the requirements and the Docker image will automatically get updated. So there's quite a lot to talk about this. So let's just run it with auto debug feature set to false. So this is essentially an autocoder, which allows you to work with a single file and iterate over it. And it also has auto debugging features. As you can see, we would actually automatically create a Docker client and pruned unnecessary images and containers. So a lot has happened already, but at a basic level, we can, all you have to do is just give it some instructions for a code, and our file name is main.py. So we are working with a Python file. Let's just go ahead and ask for a simple scatter plot, and we are working with Claude Opus, and I am using the Claude Unified. And if you want to learn more about Claude Unified, you can actually watch the Easy Opus Autocoder or Dueling Autocoders. So this simple Opus Autocoder actually goes into more details about it. So here we got this response from Opus, and actually we've saved it to main.py. So this is the file that we have that Opus has returned. So you can actually run this. You can make modifications over this file. You can run it yourself, for example, with a split terminal. That's all that is fine. And you can actually iterate over this file like we did with the other autocoders. But the purpose of this is the autocoder feature. But remember, we set the auto debug feature, and we set the auto debug to false, but actually we can execute it with --e, and we can actually give it a number. For example, I can say --e and -1. That means execute this code one time. And we are using the container. So currently we just ran it in this autocoder container. It's named autocoder because that's the name that we've given it. And it says the execution was successful. Now I can actually say, or actually instead of asking, I can go ahead and make an error in this. I'm just going to introduce a basic simple error. I just deleted this closing bracket. And then I'm going to run this again one time. I can actually specify to run it twice. Let's actually go ahead and do that. So we tried to run it one time and it got an error. And now that was sent automatically to Opus. Opus is fixing it. And once it returns it, we're going to run it one more time because we said twice. And then the second time it was successful. So even if I were, so I can manually execute auto debugger. This is nice. I can specify as many times as I like, but if the execution is successful, it'll auto cancel, meaning it'll go back to you. Now, so far, we've used the Docker container to execute this. That's why we actually didn't see any plot or anything like that. Here, as you can see, we are actually showing the plot, but you can't see the plot from a Docker container. So I can actually change the execution environment to local by saying --c--l. C here is for change and L is for local. I know maybe this is not the best naming convention, but there's not too many of these things. So now it says local execution mode enabled. Now I say --e-1, meaning execute this code once. We get to see the scatter plot, plus the execution was successful. I can say change it to bar chart, and then we should now get some new code, which is going to override this main. So this has a lot of flexibilities. Obviously, you can modify the file itself. You can run it within the container, and you can run it locally. I mean, within your own environment. By the way, before I continue these code files, we're going to talk about the code, but will be available at my Patreon at the architect level. Thank you for your support, and the link will be in the description. So like I was saying, you can actually modify this file and I run it. For example, here it says MP range 10. You can change it to 20. Do whatever you like here, and whatever changes you make will actually be sent back to Claude. We don't keep track of a conversation history other than our current conversation, our instruction, plus this file, plus when we are auto debugging, the error messages which we get. Now, here's the thing. Let's start talking about some technical details. So for Docker Desktop to work and to automatically create containers and stuff, you do need to have Docker Desktop installed. It's at docker.com, just to make a search for it. If I don't forget, I'll put it in the description as well. So you download it. That is your container Docker. So your sort of Docker engine needs to be running. It's all very simple, really. You don't even have to sign in or anything like that. And then you also need the Docker library, you're going to use to manage the containers and images. You also need Anthropic for Opus API and term color for colorful printing in the terminal. If I go ahead and delete these containers and even the images, I can go ahead and delete that. Now, as you see, we have requirements.txt. So the requirements.txt is actually for this project, for the Opus Auto Debugger project. And auto requirements is actually for the container, Docker container. So it has matplotlib in it, but I'm going to go ahead and delete it. Okay, and then now I'm going to rerun this script, the Opus Auto Debugger. And when I do that, you will see that creating a Docker client created, printing images, building a Docker image for autocoder. So now it's going to go ahead and create an image, and you can see the image details. So we can start talking about the code here a little bit as well. So as you can see, we create a Docker file, which is going to use Python 3.11, which we have specified, and it's going to copy the auto requirements to the container and actually run a pip install -r auto requirements.txt. And when all that is done, and we are doing it here, of course, through a Python script. And when we do that, we see that we've created 2 images. This Python image is downloaded from Docker for 3.11, so we do need that. And we have our autocoder image. And if you go in here, you see what has taken place there. Like, say, we pip installed auto requirements.txt. And here's our containers. Now, it does create additional containers when dealing with the image, but these are going to get cleaned up with the pruning functionality. So we will actually prune it, these ones shortly, but we do see that our autocoder is running. So this is what we wanted. Now, actually, if we go ahead and now try to execute this, and the default execution environment is Docker, I'm saying --e. E stands for execution, and 1 is the how many times I want to try to execute it, because you may want to give Opus a few chances to debug. Maybe it'll take it 2 or 3 times. So you can actually set how many times you want to try to debug. Now, when we try to do that, we get an error from the Docker that says no module name matplotlib. And the Opus is actually going to respond to us, but there's nothing that it can do at this point. But what we can do is actually we can add matplotlib to our auto requirements, because now our main file actually requires, and actually it also requires NumPy. Perhaps let's add that too to our auto requirements. NumPy. So now next time we try to run code, -e-1, for example, let's run it. It auto detects that requirements have changed, and it's going to go ahead and clear these and create new images. Hopefully, that's what we are expecting to happen anyway. So I actually had to add this pruning inside of this function too, which actually checks create or update container each time we try to auto execute. So actually, if I rerun this, we shall see that these containers are pruned away. So currently they linger. Sorry, it was my bad, but as you see, they just disappeared. When you prune it, that's a way of saying if there's anything that's not running, just get rid of it. That's what happens. Another important thing is that we are pruning client.images prune. We're pruning the images, we are pruning the containers, but I'm also pruning the dangling images as well. So I don't understand Docker perfectly, but sometimes the Docker images create container, and then that container gets deleted, let's say, but then the image kind of lingers. That's called, I believe, dangling. So we are actually removing those as well. So anyway, now we have a new container based on our requirements. So if we now try to run -e-1, we actually, execution was successful. We actually get to print something, but we don't get to see that plot. So we can actually change to local execution and then -e-1 again. Oh, okay. Actually, we weren't showing in a plot. So anyway, we were just printing, but nevertheless, the execution is successful. So if I want to start a new project, or if you wanted to actually pick up a project, make sure to paste your project here in the main.py file. And that's the name of the file you specify here in the beginning of the script. But we can actually go ahead and delete this and rerun this script if we want it. And we can actually run it by setting autodebug to true. Now, if we run it with autodebug to true with each iteration, it will actually try to execute the script twice by default. And that happens here because the execute code with retries actually takes in execution mode, whether Docker or local, and actually takes in max retries. Now, at the end of the day, the Docker is actually local as well, but it's actually like separate than from your system. It's like a virtual machine, I guess I should have said. And when autodebugger is true, we call this execute code with retries, with 2 retries. Let's ask for a simulated real-time chart of a stock price updated every 0.3 seconds. So we're going to try to simulate a stock price going up and down throughout the day, but it's going to update hopefully every 0.3 seconds. So let's see what happens. Now, as you can see, we automatically tried auto-executing main.py file, and now we're getting no module named matplotlib because our auto requirements didn't. Actually, when I try to run this code, which is supposed to create a real-time price update, right? Since it doesn't have any break conditions, so now it's running in our Docker. However, now we are unable to break out of it. So you should keep in mind that this is if you create infinite loops or unstopping loops, such as like a while loop, then there is no way with this system to actually break out of it, rather than, for example, stopping the container itself. Let's actually try that. Yeah, and then I was trying to keyboard interrupted. So if this happens, just either stop your Docker container so that your terminal becomes free. You can also delete, kill the terminal. Okay, this is why you may not always want to have auto debug set to true. But let's actually run it one more time. And I'm asking it set a 3-second limit to the loop. So since it knows this is the file we're working on, it's going to modify it so we won't have an infinite loop. Okay, and it's attempting to execute it, and it worked. And after 3 seconds, it actually stopped, and it didn't run it the second time. We can switch to --c--l to switch to local, so we can run it again to see if the plot would occur. Yeah, okay, so we are not actually doing a plot again, but just printing. Let's actually say, please display this. Okay, I said please display this as a real-time plot. The reason why the code changed, actually, it's not Opus's fault. I had to run this several times to try to debug an issue that I ran into. So this code is actually, there may be some slight bugs into it, but it works well most of the time. Just keep that in mind. And it will be available at my Patreon. This is going to be a long video, but we're going to talk about the code shortly. Just want to show you all the features. Okay, we are auto-executing the file. And we are auto-executing in Docker again. Oh, no, never mind. Yeah, here we go. The plot was drawn, and then it was also printed. Let's run this one more time to see if it was being done. Oh, we are still in Docker. That's why we only get to see the final image. But we see that the code executes, so there's no need for it. I'm going to switch to local and then execute it one more time. Maybe it is not actually, it's not displaying it as a real-time chart. That's why what's happening. Let's say, please display the information in real time. And like a simulation, let's say, and make the loop 5 seconds long. Let's see. So this gives you a lot of opportunities to both modify the file and keep making updates. Okay, we got our file and the final explanation. I didn't want to, you can actually instruct it to not to return explanations after the code. But I thought it would be, if you wanted to really work on a complex project, it would be nice to see some explanation. Okay, we're attempting to execute it. Attempt number 1 of 5. Okay, either our plot is delayed, but it's drawing it, but it did not show it in real time. But that's fine, it worked, nevertheless. Let me show you one more thing we can do. Let me delete this main.py file. And so usually speaking, this is designed to work with .py files, but it's not limited to that. I can actually say index.html and rerun this code, of course. And when you have the auto debug through and you have an HTML file, it'll actually use the web browser to actually show you what's going on. I'm going to ask for a gravity simulation with 5 different objects, and it's writing an index.html file. And right after this code is done, we should launch it automatically with web browser. So we can see there's no way, as far as I know, to get actually debugging error messages from the browser itself. But at least this way it launches it automatically and you get to see what's going on. See, here we go. This actually kind of worked. So we could have also bring up the developer tools, Control-Shift-I, and look at the console. There's no error messages. But if there was any, we could have copied it and pasted it back to Opus, the auto debugger. Let's ask it to make it interactive. So this is to say you can work with HTML files and .py files, but this is designed to really work with only a single file. So far, feel free to modify it. Okay, we're almost done. Yeah, there we go. We did ask for a interactive one, but it didn't really make it interactive. Mouse down, mouse down. Maybe it is. Let's try again. Oh, okay. No, never mind. We can pick them up. Yeah, it is interactive. That's nice. See, there we go. So Opus is really good. And I do want to just mention that the reason why Docker is there is so that you can, execute your code safely. And the local option is there if you just wanted to, it's simpler, but nevertheless, both options are there. And --e number specifies to manually execute the file and how many times. If you set auto debugging to true, then it will try auto debugging it for at least twice. That's the same as running this twice. And --c is to change. to Docker -c-d means change the execution environment to Docker -c-l means change the execution environment to local. That's about it. So now let's talk about the code. We are using Cloud Unified, and Cloud Unified is a class that I created, which just helps you setting system messages, managing history, and making calls with retries, and it just does a bunch of stuff for you. Since this file is quite long, we're not going to go too deep into it, but I do go into it. Easy Opus Auto Coder. But if you really wanted to deep dive into it, I recommend watching the OpenAI Unified API and any other video that actually features it. Pretty much most of the videos after that. And the dueling autocoders, Opus versus GPT-4 features it too. So it just makes life simpler. As you can see, this auto debugger is 266 lines of code. If we were to include everything here, it's going to be 400. It'll just be too much. But we are just using that to simplify our lives. We are instantiating a cloud chat with streaming set to true, mix history were set to 0. We have auto debug either set to false. I think maybe say having a false to begin with is nice because you can always use the --e command. You set a file name. Let's set this back to main.py, and this will determine the file that you're working with, and you're going to iterate over. And then the image container name determines what you're going to give the name of the image and the container for Docker. And then we have a system message. We set the Claude system message saying, I would appreciate if you can help me with some coding project. And it's going to return it in these brackets using the file name. And then there's some other instructions here. And we set the default execution mode to -d, which means Docker. And then we check if we have auto debug. And then this part of the code is actually redundant, I suppose. I wanted to ask in the beginning to the user if they wanted to change to use Docker or local, but you can actually change it. Now that I think this is actually too verbose, I could have just done -d or -l. Anyway, the way it is, if you want to change your execution environment, just do -c for change and L for local, for example. It'll give you visual information. Anyway, if it's Docker, then we create a client with docker.from-env. This is just a standard. And we give a name to the image and default image and container name, which is the image container name, which we set here, which is autocoder. And then we are calculating the hash of the auto requirements.txt file using the hash lib, which we have imported. So this is just going to get a hash of it and return it. So this is how we're actually going to compare it, if auto requirements have changed. So just to try it out, I changed the requirements, the auto requirements, removed NumPy, and it detected it. So, I hope there's not a lot of bugs in this code, but if sometimes, let me remove this too and try to execute -1. Yeah, requirements have changed, updating the image. So this should work, and hopefully, because the main.py. Okay, actually, sorry about that. If we don't have a main.py and try to execute it, obviously, then it gets an error message. Also, I just noticed my recording automatically stopped because I ran out of hard disk space. So I tried to make this pruning Docker resources more robust. Docker do take a lot of space, and when I restarted my computer, then everything came back to normal. But it should work fine for the most part. But when you're running it, do keep track of your hard drive space. This image is prune, containers prune, and I also had volumes prune. Should actually remove it. If not, do take a look at this resources part of Docker, perhaps. Yeah, and I also forgot to mention that when you're running Docker desktop, you do need Windows WSL installed as well. So Windows WSL2, and you can actually find quite a lot of resources on how to install. Just make a search for it. Also keep that in mind as well. Okay, because Docker does require it. Anyway, I actually added this function here, prune Docker resources. And instead of doing all that, we're actually calling this function right after calculate requirements hash, which actually returns the hash of the auto requirements. Then we have this prune Docker resources. Then we have create or update image. Let me zoom in a little bit more, which is going to take an image and requirements hash as a global variable. And we're going to get a current requirements hash calling this calculate requirements hash function. And then we're going to try to get an image using the Docker client images.get with that name. If that exists, then we print. If not, we check the current requirements hash in comparison to that image's requirement hash. And if they don't match, then we print requirements have changed, then we remove that image. And then if there was any error finding the image, then we raise an error. Otherwise, we are going to build a Docker image with a Python 3.11 using the autorequirements.txt. We create a temporary Docker file, and then we use client.images_build with that name using that current requirements hash. And now we have printed. Then we can now remove the Docker file, which was temporarily created over here. And now we have the creator update container, which is going to call creator update image. Of course, we do need an image to create a container. And now we're going to try to get a name. If it doesn't exist, then we are going to check creating the container. The requirements is checked when we are creating the image. So this should be taken care of right here. And if this container doesn't exist, then we are going to create a container with that image's ID that we have just created, the name, and with the read and write mode true. By the way, if anybody knows if there's a better way to clean up Docker images and volumes and containers, do let me know in the comments or at Discord. By the way, if you're enjoying my videos, I have over 250 projects. You can watch the videos here on my website, echohive.live, which are the YouTube videos I've created. And if you're a patron, you can find the code download links. When you become a patron, you'll have access to over 200 project files. You can also check out some of my apps, such as CodeHive, which comes with 900 plus GPT-powered Python projects, and each one of them already have the code free. This is a completely free app, but if you like what you see, then you can download all of them from my Patreon shop for $100. I also have the Auto Streamer, which auto creates contents and build course websites in real time. And you can actually check out this. You can actually check out the live stream that I made, and this is the website we've created in real time. And I show at the end of the live stream how to deploy it. And if you do become a patron, I really do appreciate it, because this is all I do all day long, and it gives me more time to build interesting projects. Anyway, and we create a container, right? And we print that. And if the container is not running, then we actually start the container, and now we are putting the Docker resources, trying to free up some space. We call this in the script when we first run the script, and also we call it every time we're calling creator update container. So at this point, we check what the execution mode was. We've set it here at the top, but we can actually change it right through when we enter our while loop. But if it's Docker, then we create our update container, and then we define a new function called execute code with retries, which is going to take in a file name, max retries, and execution mode. And again, in the beginning of this function, we do creator update containers. This is just to make sure that the container requirements are matched with autorequirements.txt. We say attempt at 0 while attempts is less than max tries. Then if it is, if we are in the Docker mode, then we call the container.exec run. We get the exit code and output. Otherwise, we use the subprocess. Okay, and then we get the exit code and output, and then if the exit code is 0, then the execution was successful. We print the output. Otherwise, we print the error message. And then we read the contents of our current files, such as like the main.py. And now we create a new message to Claude saying there was an error when executing the file name. This was the error message. Please check the code and fix any issues if needed. Here's the code where the error occurred, and this is the current code, which we read from the file. And now we use the Claude.chat of the Claude Unified, which automatically actually gets the response for us. It just simplifies it. Then we get our response. We split it to look for the tags with the file name. We get the code from that, and we overwrite the file. We increment the attempt. In any case, we break out of this if the exit code was 0. That means execution was successful, so we don't keep rerunning it again and again. So this was all really like a setup, prelude, all the functions. And at this point, we enter a while loop. This is pretty much where you just enter your input, right? Your instructions. You can do --e-- number that is to execute code manually. Why do we want to do this? Because you don't want to always. So usually speaking, say if you have auto debug set to true, then you're going to get the code which is returned from Opus run, right? And get any error messages, if any. But maybe sometimes you have some piece of code where you know where the error is, or you may want to add some things to it, or maybe you want to work with ChatGPT and then update this file, and then you can actually call this --e and then execute that code. And then so you can do that actually manually, and you can specify how many times you want to try, and you can also set your execution environment --c--d for Docker, --c--l for local. It defaults to Docker. That's why the C here stands for change. And if you type in exit, we break out of this. And if this is the check, if the user input includes --e-, then we get the max tries number by splitting it using a method. And if, by the way, if the file ends with an HTML, then we just use web browser to open that so you can visually see and inspect what's going on. And I check the browser console for any error messages because there's no way to actually get the error message. Maybe we can use actually vision capabilities, but this was already pretty complex. I didn't want to do that. Otherwise, if it's not HTML, then we execute code with retries. Remember, this was the code that we looked at, which either runs it with a container or subprocess. And then that's about it. Here, if we set --c then we check for D or an L, and we set the execution mode to that pretty much. Yeah, and if it's Docker, then we print it. So there's quite a lot of print statements here to make things easy to understand. And we check if the file name exists in the current folder, check, and the meaning. See, because we take in a user input, right? This is the instructions, but we check to see if actually main.py file in this case exists. So if it does exist, then we modify the user input to say this is the file we're working on. We give the file name and the file contents, plus we give the user input. So if there's no file that we're working on, maybe we just started, then your original instruction goes through. If not, this augmented instruction goes to Claude, again using claude.chat. And now when the code response comes in, then we write it to file, then we initialize an error message, and we check if we have auto debug set to true. If it is, then we auto execute that file. If it's HTML, we just open it with web browser. Otherwise, we call the execute code with retries. Whether it's Docker or subprocess doesn't really matter here, and I get the error message. And once we exit this, if you don't break out of this, maybe you know what? This is why we weren't removing the containers. Okay, I see now. Because I was breaking out of this terminal, it's best to just exit it gracefully. I guess let's do that and see what happens. Oh, it's going to create a new image because I modified the auto requirements, but let's wait for it. So what's going to happen is essentially when we exit, it checks if we are in a Docker container. Let's do that actually. Yeah, stopping and removing container. So we are actually removing this container. Let's see what happens. Okay, the images are here. Containers are removed. Images had an issue. Let me delete. You can also delete it manually. Set autocoder latest. I'm not sure why that happened. Container stop remove. Container image remove. Yeah, this should work normally, but yeah, just do use that exit. Like I said, this code may have just a few bugs, but it should work well for the most part. So this is about it. This requirements.txt is for this project, and auto requirements is for whatever project that you're working on. Okay, so this will be available at Patreon. If you do become a patron, you'll have access to over 200 projects. This is all I do. I try to think of interesting new projects, and I provide the code files as an example to my patrons. So it really is a convenience. It saves you a lot of time. Just download the code, modify it. So thank you to all my supporters. And if you do become a new patron, I do appreciate your support. Thank you very much, and I'll see you in the next video.